Antivirus, or AV software is computer software used to prevent, detect and remove malicious computer viruses. Most software described as antivirus also works against other types of malware, such as malicious browser helper objects, browser hijackers, ransomware, keyloggers, backdoors, rootkits, trojan horses, worms, malicious LSPs, dialers, fraudtools, adware and spyware. Computer security, including protection from social engineering techniques, is commonly offered in products and services of antivirus software companies. This page discusses the software used for the prevention, detection, and removal of malware threats, rather than computer security implemented by software methods. A variety of strategies are typically employed. Signature-based detection involves searching for known patterns of data within executable code. However, it is possible for a computer to be infected with new malware for which no signature is yet known. And malware is often modified to change its patterns without affecting functionality. To counter such zero-day viruses, heuristics can be used. One type of heuristic approach, generic signatures, can identify variants by looking for slight variations of known malicious code in files. Some antivirus software can also predict what a file will do by running it in a sandbox and analyzing what it does to see if it performs any actions which could be malicious. Antivirus software has some drawbacks. It can impair a computer's performance. Inexperienced users can be lulled into a false sense of security when using the computer, considering themselves to be totally protected, and may have problems understanding the prompts and decisions that antivirus software presents them with. An incorrect decision may lead to a security breach. If the antivirus software employs heuristic detection, it must be fine-tuned to minimize misidentifying harmless software as malicious. Antivirus software itself usually runs at the highly trusted kernel level of the operating system to allow it access to all the potential malicious process and files, creating a potential avenue of attack. History. Most of the computer viruses written in the early and mid-1980s were limited to self-reproduction and had no specific damage routine built into the code. That changed when more and more programmers became acquainted with virus programming and created viruses that manipulated or even destroyed data on infected computers. There are competing claims for the innovator of the first antivirus product. Possibly the first publicly documented removal of a computer virus in the wild was performed by Bandfix in 1987. There were also two antivirus applications for the Atari ST platform developed in 1987. The first one was G-Data and second was UVK 2000. Fred Cohen, who published one of the first academic papers on computer viruses in 1984, began to develop strategies for antivirus software in 1988 that were picked up and continued by later antivirus software developers. In 1987, he published a demonstration that there is no algorithm that can perfectly detect all possible viruses. In 1987 the first two heuristic antivirus utilities were released, FlushHot Plus by Ross Greenberg and Antivirus by Owen Lanting. Also in 1988 a mailing list named VirusL was started on the BITNET network where new viruses and the possibilities of detecting and eliminating viruses were discussed. Some members of this mailing list like John McAfee or Eugene Kaspersky later founded software companies that developed and sold commercial antivirus software. Before Internet connectivity was widespread, viruses were typically spread by infected floppy disks. Antivirus software came into use, but was updated relatively infrequently. During this time, virus checkers essentially had to check executable files and the boot sectors of floppy disks and hard disks. However, as Internet usage became common, viruses began to spread online. Over the years it has become necessary for antivirus software to check an increasing variety of files, rather than just executables, for several reasons. Powerful macros used in word processor applications, such as Microsoft Word, presented a risk. Virus writers could use the macros to write viruses embedded within documents. This meant that computers could now also be at risk from infection by opening documents with hidden attached macros. The possibility of embedding executable objects inside otherwise non-executable file formats can make opening those files a risk. Later email programs, in particular Microsoft's Outlook Express and Outlook, were vulnerable to viruses embedded in the email body itself. A user's computer could be infected by just opening or previewing a message. As always-on broadband connections became the norm, and more viruses were released, it became essential to update virus checkers more and more frequently. Even then, a new zero-day virus could become widespread before antivirus companies released an update to protect against it. Identification method. One of the few solid theoretical results in the study of computer viruses is Frederick B. Cohen's 1987 demonstration that there is no algorithm that can perfectly detect all possible viruses. There are several methods which antivirus software can use to identify malware. Signature-based detection is the most common method. To identify viruses and other malware, antivirus software compares the contents of a file to a dictionary of virus signatures. Because viruses can embed themselves in existing files, the entire file is searched, not just as a whole, but also in pieces. Heuristic-based detection, like malicious activity detection, can be used to identify unknown viruses. File emulation is another heuristic approach. File emulation involves executing a program in a virtual environment and logging what actions the program performs. Depending on the actions logged, the antivirus software can determine if the program is malicious or not and then carry out the appropriate disinfection actions. Signature-based detection. Traditionally, antivirus software heavily relied upon signatures to identify malware. This can be very effective, but cannot defend against malware unless samples have already been obtained and signatures created. Because of this, signature-based approaches are not effective against new, unknown viruses. As new viruses are being created each day, the signature-based detection approach requires frequent updates of the virus signature dictionary. To assist the antivirus software companies, the software may allow the user to upload new viruses or variants to the company, allowing the virus to be analyzed and the signature added to the dictionary. Although the signature-based approach can effectively contain virus outbreaks, virus authors have tried to stay a step ahead of such software by writing oligomorphic, polymorphic, and, more recently, metamorphic viruses, which encrypt parts of themselves or otherwise modify themselves as a method of disguise, so as to not match virus signatures in the dictionary. Heuristics. Some more sophisticated antivirus software uses heuristic analysis to identify new malware or variants of known malware. Many viruses start as a single infection and through either mutation or refinements by other attackers, can grow into dozens of slightly different strains, called variants. Generic detection refers to the detection and removal of multiple threats using a single virus definition. For example, the Ubuntu Trojan has several family members, depending on the antivirus vendor's classification. Symantec classifies members of the Ubuntu family into two distinct categories, Trojan Ubuntu and Trojan Ubuntu B. While it may be advantageous to identify a specific virus, it can be quicker to detect a virus family through a generic signature or through an inexact match to an existing signature. Virus researchers find common areas that all viruses in a family share uniquely and can thus create a single generic signature. These signatures often contain non-contiguous code, using wildcard characters where differences lie. These wildcards allow the scanner to detect viruses even if they are padded with extra, meaningless code. A detection that uses this method is said to be heuristic detection. Rootkit detection. Antivirus software can attempt to scan for rootkits. A rootkit is a type of malware that is designed to gain administrative-level control over a computer system without being detected. Rootkits can change how the operating system functions and in some cases can tamper with the antivirus program and render it ineffective. Rootkits are also difficult to remove, in some cases requiring a complete reinstallation of the operating system. Real-time protection. Real-time protection, on-access scanning, background guard, resident shield, auto-protect, and other synonyms refer to the automatic protection provided by most antivirus, anti-spyware, and other anti-malware programs. This monitors computer systems for suspicious activity such as computer viruses, spyware, adware, and other malicious objects in real time. In other words, while data loaded into the computer's active memory, when inserting a CD, opening an email, or browsing the web, or when a file already on the computer is opened or executed. Issues of concern: unexpected renewal costs. Some commercial antivirus software end-user license agreements include a clause that the subscription will be automatically renewed, and the purchaser's credit card automatically billed, at the renewal time without explicit approval. For example, McAfee requires users to unsubscribe at least 60 days before the expiration of the present subscription, while Bitdefender sends notifications to unsubscribe 30 days before the renewal. Norton Antivirus also renews subscriptions automatically by default. Rogue security applications. Some apparent antivirus programs are actually malware masquerading as legitimate software, such as WinFixer, Miss Antivirus, and Mac Defender. Problems caused by false positives. A false positive is when antivirus software identifies a non-malicious file as a virus. When this happens, it can cause serious problems. For example, if an antivirus program is configured to immediately delete or quarantine infected files, as is common on Microsoft Windows antivirus applications, a false positive in an essential file can render the Windows operating system or some applications unusable. Recovering from such damage to critical software infrastructure incurs technical support costs, and businesses can be forced to close whilst remedial action is undertaken. For example, in May 2007 a faulty virus signature issued by Symantec mistakenly removed essential operating system files, leaving thousands of PCs unable to boot. Also in May 2007, the executable file required by Pegasus Mail on Windows was falsely detected by Norton Antivirus as being a Trojan, and it was automatically removed, preventing Pegasus Mail from running. Norton Antivirus had falsely identified 3 releases of Pegasus Mail as malware, and would delete the Pegasus Mail installer file when that happened. In response to this, Pegasus Mail stated, in April 2010, McAfee Virus Scan detected svcostix, a normal Windows binary, as a virus on machines running Windows XP with Service Pack 3, causing a reboot loop and loss of all network access. In December 2010, a faulty update on the average antivirus suite damaged 64-bit versions of Windows 7, rendering it unable to boot, due to an endless boot loop created. In October 2011, Microsoft Security Essentials removed the Google Chrome web browser, rival to Microsoft's own Internet Explorer. MSE flagged Chrome as a ZBOT banking Trojan. In September 2012, Sophos antivirus suite identified various update mechanisms, including its own, as malware. If it was configured to automatically delete detected files, Sophos antivirus could render itself unable to update, required manual intervention to fix the problem. System and interoperability-related issues. Running multiple antivirus programs concurrently can degrade performance and create conflicts. However, using a concept called multi-scanning, several companies have created applications which can run multiple engines concurrently. It is sometimes necessary to temporarily disable virus protection when installing major updates such as Windows Service Packs or updating graphics card drivers. Active antivirus protection may partially or completely prevent the installation of a major update. Antivirus software can cause problems during the installation of an operating system upgrade, for example when upgrading to a newer version of Windows in place without erasing the previous version of Windows. Microsoft recommends that antivirus software be disabled to avoid conflicts with the upgrade installation process. The functionality of a few computer programs can be hampered by active antivirus software. For example, TrueCrypt, a disk encryption program, states on its troubleshooting page that antivirus programs can conflict with TrueCrypt and cause it to malfunction or operate very slowly. Antivirus software can impair the performance and stability of games running in the Steam platform. Support issues also exist around antivirus application interoperability with common solutions like SSL VPN remote access and network access control products. These technology solutions often have policy assessment applications which require that an up-to-date antivirus is installed and running. If the antivirus application is not recognized by the policy assessment, whether because the antivirus application has been updated or because it is not part of the policy assessment library, the user will be unable to connect. Effectiveness. Studies in December 2007 showed that the effectiveness of antivirus software had decreased in the previous year, particularly against unknown or zero-day attacks. The computer magazine CT found that detection rates for these threats had dropped from 40 to 50% in 2006 to 20 to 30% in 2007. At that time, the only exception was the NOD32 antivirus, which managed a detection rate of 68%. The problem is magnified by the changing intent of virus authors. Some years ago it was obvious when a virus infection was present. The viruses of the day, written by amateurs, exhibited destructive behavior or pop-ups. Modern viruses are often written by professionals, financed by criminal organizations. Independent testing on all the major virus scanners consistently shows that none provide 100% virus detection. The best ones provided as high as 99.9% detection for simulated real-world situations, while the lowest provided 91.1% in tests conducted in August 2013. Many virus scanners produce false positive results as well, identifying benign files as malware. Although methodologies may differ, some notable independent quality testing agencies include AV Comparatives, ICSA Labs, West Coast Labs, Virus Bulletin, AV Test and other members of the Anti-Malware Testing Standards Organization. New viruses. Antivirus programs are not always effective against new viruses, even those that use non-signature-based methods that should detect new viruses. The reason for this is that the virus designers test their new viruses on the major antivirus applications to make sure that they are not detected before releasing them into the wild. Some new viruses, particularly ransomware, use polymorphic code to avoid detection by virus scanners. Jerome Segura, a security analyst with Para2 Logic, explained, a proof-of-concept virus has used the graphics processing unit to avoid detection from antivirus software. The potential success of this involves bypassing the CPU in order to make it much harder for security researchers to analyze the inner workings of such malware. Rootkits. Detecting rootkits is a major challenge for antivirus programs. Rootkits have full administrative access to the computer and are invisible to users and hidden from the list of running processes in the task manager. Rootkits can modify the inner workings of the operating system and tamper with antivirus programs. Damaged files, files which have been damaged by computer viruses, for example by ransomware, may be damaged beyond recovery. Antivirus software removes the virus code from the file during disinfection, but this does not always restore the file to its undamaged state. In such circumstances, damaged files can only be restored from existing backups or shadow copies. Installed software that is damaged requires reinstallation. Firmware issues. Active antivirus software can interfere with the firmware update process. Any writable firmware in the computer can be infected by malicious code. This is a major concern, as an infected BIOS could require the actual BIOS chip to be replaced to ensure the malicious code is completely removed. Antivirus software is not effective at protecting firmware and the motherboard BIOS from infection. Other methods. Installed antivirus software running on an individual computer is only one method of guarding against viruses. Other methods are also used, including cloud-based antivirus, firewalls and online scanners. Cloud antivirus. Cloud antivirus is a technology that uses lightweight agent software on the protected computer, while offloading the majority of data analysis to the provider's infrastructure. One approach to implementing cloud antivirus involves scanning suspicious files using multiple antivirus engines. This approach was proposed by an early implementation of the cloud antivirus concept called Cloud AV. Cloud AV was designed to send programs or documents to a network cloud where multiple antivirus and behavioral detection programs are used simultaneously in order to improve detection rates. Parallel scanning of files using potentially incompatible antivirus scanners is achieved by spawning a virtual machine per detection engine and therefore eliminating any possible issues. Cloud AV can also perform retrospective detection, whereby the cloud detection engine rescans all files in its file access history when a new threat is identified, thus improving new threat detection speed. Finally, Cloud AV is a solution for effective virus scanning on devices that lack the computing power to perform the scans themselves. Some examples of cloud antivirus products are Panda Cloud Antivirus and Immunit. Network firewall. Network firewalls prevent unknown programs and processes from accessing the system. However, they are not antivirus systems and make no attempt to identify or remove anything. They may protect against infection from outside the protected computer or network, and limit the activity of any malicious software which is present by blocking incoming or outgoing requests on certain TCP/IP ports. A firewall is designed to deal with broader system threats that come from network connections into the system and is not an alternative to a virus protection system. Online scanning. Some antivirus vendors maintain websites with free online scanning capability of the entire computer, critical areas only, local disks, folders or files. Periodic online scanning is a good idea for those that run antivirus applications on their computers because those applications are frequently slow to catch threats. One of the first things that malicious software does in an attack is disable any existing antivirus software, and sometimes the only way to know of an attack is by turning to an online resource that is not installed on the infected computer. Specialist tools. Virus removal tools are available to help remove stubborn infections or certain types of infection. Examples include Trend Micro's Rootkit Buster, and RootHunter for the detection of rootkits, Avira's Antivirus removal tool, BHOs threat removal tool, and Average's Antivirus Free 2011. A rescue disk that is bootable, such as a CD or USB storage device, can be used to run antivirus software outside of the installed operating system, in order to remove infections while they are dormant. A bootable antivirus disk can be useful when, for example, the installed operating system is no longer bootable or has malware that is resisting all attempts to be removed by the installed antivirus software. Examples of some of these bootable disks include the Avira Antivirus Rescue System, BHOs Alternate Operating System Scanner, and Average Rescue CD. The Average Rescue CD software can also be installed onto a USB storage device that is bootable on newer computers. Usage and risks. According to an FBI survey, major businesses lose $12 million annually dealing with virus incidents. A survey by Symantec in 2009 found that a third of small to medium-sized business did not use antivirus protection at the time, whereas more than 80% of home users had some kind of antivirus installed. According to a sociological survey conducted by G-Data Software in 2010, 49% of women did not use any antivirus program at all. See also: Antivirus and Anti-Malware Software, CARO, the Computer Antivirus Research Organization, Comparison of Antivirus Software, EICAR, the European Institute for Computer Antivirus Research, Firewall Software, Internet Security, Linux Malware, List of Computer Viruses, List of Trojan Horses, Quarantine Technology, Sandbox, Timeline of Notable Computer Viruses and Worms, Virus Hoax, References. Bibliography. External links: Antivirus software at DMOZ.